Alright, so in this video, we're going to continue on the number of ways we can have something happen. So we talked about the fundamental counting principle, but today we're going to talk about permutations. Now, permutations are all possible arrangements being a keyword of a collection of things where order is important. So the big key thing here is that a permutation is used when order is important. So that's why I'm going to highlight that. Now, how do we tell the fundamental counting principle from permutations? So again, we're going to use the fundamental counting principle, which I'm going to abbreviate, when given options, but order doesn't matter. So again, key order doesn't matter. You're given multiple options. We use permutations when order matters. And choosing one option takes away from the beginning pool of options. Alright, so notation of permutations. There are two ways you'll see this. A lot of problems in your book show it P, N, R. Now, the other way, though, your calculator is going to use is N, P, R. So this is actually the more common way, but you're going to see it written this way in your book more. So what is this formula? What do the parts mean? So P tells me that I'm doing a permutation. So P is permutation. N is the total amount of elements. So total elements you're choosing from, basically. And R is the number of subset chosen. So usually we say this as n things taken at n time, or n pick R at a time. That's another way that you'll hear it said. Alright, so two examples here. How many ways are there to fill vice president, or president, vice president, treasurer for student council if 12 people are running, assuming no one holds more than one role? So how do I tell if this is a permutation or counting principle? Well, this tells me I have three options here, but I have a total number of people here. So I have a total, and I want 1, 2, 3 positions, and that tells me that order matters. So here, order is important. So now I know that I'm going to do my total, 12, and I want to pick 3 positions, because there's 3 positions here. Or this is the same thing as saying P of 12, 3. Well, how do we write these out? Again, here, going back up here, we use n factorial over n minus r factorial. So n factorial is 12 factorial, divide out 12 minus 3 factorial. So we have 12 factorial over 9 factorial. And you can pop that in your calculator or whatever you want to do to get your number, 1320, and that's the answer. Alright, so let's go on to the next one. 4 athletes will be chosen from a group of 20 for a Gatorade Athletes of the Year. The 4 categories MVP, Most Improved Sixth Man and Newcomer Award. No one can get an award more than once. How many different ways can there choose? So the big thing here is this sentence tells us that order is important again. So order matters. Therefore, we're going to do a permutation. How many people do we have? We have 20. How many awards are there? There's 4. Alright, so then that becomes, again, if you want to see it the other way, 20p4. And we use our n factorial, so 20 factorial over 20 minus 4 factorial. So 20 factorial over 16 factorial. Alright, so then that equals 116,280. Again, if you need a refresher on how to put those in your calculator, let's go ahead and do 20 factorial, math to probability, and then 20 factorial, we're going to divide by, in this case, 16 factorial. So math, probability, arrow down, and we get our number. Alright, so there's a little review. Well, what about doing these in your calculator? You can do these too. Type in the number of elements, so we have 20. Scroll to math, probability, you may have realized that there's this NPR here. So hit NPR, and how many I'm choosing? Subset, 4. I get the same exact answer. So you can do that there. Alright, now let's do a few more examples before you go off and do some on your own. So Julie has to pick up 5 things from 5 different stores while she runs errands. How many different ways are there to pick up 3 things that she needs? So there's not a lot of options going on here. So we've got pick up 5 things from 5 different stores. So 5 total things she needs. How many is she going to pick up before she runs out of time? 3 things. So I need a permutation, because order matters if we're going to run out of time. I've got 5, and I am picking 3 things. So again, if you want to see this the other way, 5p3, and then we can just put that in our calculator. 5, number of elements total. Probability, we need pick 3. So that's 60. Alright, that's our answer. Now let's go on to the next page. Alright, we've got a Ford Escape is available in 8 colors, 2 engine types, 3 different models. How many different Escapes are there? So this just sounds like we have different options. No order. So this is going to be your fundamental counting principle. So notice we're counting principle in permutations. Oops, sorry. So fundamental counting principle tells me multiply all the different types. I've got 8 colors, got 2 engine types, and there's 3 different models. So multiply it all together to get a grand total of 48 different Escapes. Alright, so let's keep going. Jay has 8 college visits to take during spring break. How many different ways are there for him to pick a first, a second, and a third? So 8 college visits, that sounds like a total. And then we have first, second, and third. So that sounds like R equal to 3. And we have N equals 8. So order kind of matters here. We got first, second, third. So order matters. We've got 8 total options. That's a permutation. We're picking how many? 3. So 8 pick 3. Put in your calculator. 336 different ways. Right? Playing rummy, a person has a hand of 6 cards drawn from 52. How many different hands are there that contain 2, 3, 4, 5, 6, and 7? So the question here is, does order matter? Well, do I care what order those are in? So no. Order does not matter. Well, my hand has 6 cards, so I better have 1, 2, 3, 4, 5, 6. Well, how many options are there for a 2? There's 4 in a deck of cards. So that's for 2s. How many are there for 3? There's another 4 options for 3s. And what about 4s? There's 4 options for 4s. And now we're going to go on and do 5s. There's 4 options for that as well. And 6s, 4 options. And 7s, there's also 4 options. Or you can just do 4 to the 6th power. Same thing. So in this case, there are 4,096 hands. Alright, I'm going to skip 4. This one's a you-try problem. And I want to talk about number 5. How many different ways are there to arrange, being a keyword, A, B, C, and D? So that tells me I have a total number of options that are 4 options, and I want to arrange them. So how many different ways do I arrange? 4. So 4, pick 4 different ways. That ends up being 24. Alright, now I want you to finish out those ones. So these, you try, and you try this one as well. And then come to class, we'll talk about those, and that will be done with counting principal and permutations.